In this video, I'm going to talk about completing the square. Completing the square is a way to solve a quadratic equation. So a quadratic equation is an equation that has a squared variable in it. In fact, that's the highest power of the variable that you would have in a quadratic equation is the variable squared. So this is an example of a quadratic equation. And to solve that by completing the square, we want to get all the terms with variables in them on one side of the equal sign and all of the terms that don't have variables in them on the other. So I'm going to move this 15 to the other side of the equal sign. And that's going to leave me x squared plus 10x over here. And on this side I'm going to have a 15. Now notice I left a blank right here. You're going to put plus blank and you're going to put a plus blank on the other side, because whatever you do on one side of the equal sign you have to do on the other as well. Now what we're trying to do in this blank is we're trying to fill a number in right here that will create a perfect square trinomial here. So we have x squared plus 10x plus blank, and we want to figure out what number we should put right there to make a perfect square trinomial. So to find that number, we're going to always take half of this number and square it. So the number that's in front of the x, take half of this number and square it. So we have a positive 10 right there. Half of 10 is 5, and 5 squared is 25. So that's what goes in the blank. Because we're adding 25 on this side of the equation, we've got to add 25 on this side as well. Now what we've done here, this is now a perfect square trinomial, which means if we were to factor that, it would factor to x plus 5 times x plus 5, or x plus 5 squared. That's what we were looking for, is a nice perfect square. On the other side of the equal sign, we add those numbers, we get 40. And what we've created now is a problem that we can use the square root method to solve. Once we get here, we can take the square root of each side. And when you take the square root of something that's squared, the square root and the squared just cancel each other out, and you have x plus 5 left on this side. On this side, we have to remember to put plus or minus when we take the square root. The square root of 40 will simplify to 2 square roots of 10. And then we'll move this 5 to the other side to ultimately solve the equation for x. And we'll get negative 5 plus or minus 2 square roots of 10. So our answers are negative 5 plus 2 square roots of 10 and negative 5 minus 2 square roots of 10. Remember, in a quadratic equation, because it's got the highest power is a 2, that tells you how many answers you're supposed to get. So we should always come out with 2 answers. That's where the plus or minus comes in here. Alright, so let's do a couple more completing the square problems. How about x squared minus 6x plus 13 equals 0. Okay, again, we want to get the terms with variables in them on one side. Anything that doesn't have a variable in it, we want to move it to the other side. So we're going to move the 13 over. That's going to leave us with x squared minus 6x on this side, a negative 13 over here. Again, we're going to add plus blank and plus blank. It's always going to be plus, because when we square a number, it will always come out positive whether the number was negative or positive. So we're going to take half of negative 6, which is negative 3. But when we square a negative, negative 3 squared is positive 9. So we're going to have positive 9 there and there. Again, this has created a perfect square trinomial, so that when we factor it, we know that it would be x minus 3 times x minus 3. Now, how did I know that so fast? Well, it's always going to be whatever you got when you took half of this middle number. Half of negative 6 is negative 3, and so that's what's going to go here and here. X minus 3, which is x minus 3 squared. Okay, it's Notice back over here, half of that positive 10 was positive 5, and that's what ended up here. So we have x minus 3 squared equals negative 4. Now we're set up to do the square root method. We're going to take the square root of both sides. And here the square root cancels out the squared, so we're left with x minus 3. Over here, we've got a negative under the square root. We've got to take care of that by taking out an I. That'll get rid of the negative because I is equal to the square root of negative 1. So anytime we need to simplify a negative square root, we can pull an I out front, and then that number will now be positive, and we can simplify it just like we learned to simplify square roots. That's going to end up being 2i, but we got to put a plus or minus in front of it. All right, so we have x minus 3 equals plus or minus 2i. We're going to add 3 to both sides to solve for x, and we get 3 plus or minus 2i. So our answers here are 3 plus 2i and 3 minus 2i. Okay, we're going to do just a couple more completing the square problems. How about this one? N times n minus 4 equals 7. All right, in order to get this set up to do completing the square, we're going to need to first distribute this out. N times n is n squared. N times negative 4 is negative 4n. And over here we have 7. And at this point, we are set up to do completing the square. We've got our terms with variables in them. Over here on the left, we've got our term that doesn't have a variable in it on the right. So now we're going to draw our blank. So plus blank on both sides of the equal sign. And we've got to find that magic number to fill in the blank that's going to create a perfect square trinomial. Again, we do that by taking half of the middle number. Half of negative 4 is negative 2. And then square that, and that's positive 4. So positive 4 goes here and here. Now remember, we know that this makes a perfect square. And it's always going to be the variable and then whatever you got when you took half of this middle number, which would be negative 2. So it's n minus 2 squared equals 11. Now we're set up to do the square root method. We're going to take the square root of each side. Don't forget, when you take the square root, you've got to put plus or minus. 11 is not a perfect square, and it cannot be simplified, so we just leave it the square root of 11. We'll add 2 to each side as our final step to solve for n, and we get 2 plus or minus the square root of 11, which means our answers are 2 plus the square root of 11 and 2 minus the square root of 11. One last problem. Let's do p squared plus 4p plus 6 equals 0. All right, our first step will be to move the 6 over so that everything that has a variable in it is on the left. When we subtract 6 over here, then that's the only thing that didn't have a variable in it. Now it's to the right. We'll draw our blanks here so we can complete the square. We'll take half of 4 is 2 and square that, which will be 4. So positive 4 goes here and here. We know if we did this right that it created a perfect square. It will be p and then whatever you got when you took half of the middle one, which would be positive 2. So p plus 2 squared. Negative 6 plus 4 is negative 2. Now we're going to take the square root of both sides. We know when we take the square root of a squared term, the square root and the squared just cancel each other out. That's going to leave p plus 2. Over here, we have a negative under the square root, so we know we need to pull out an I. We also know that it's going to be plus or minus. Once we pull out that I, we have a 2 left under there. That cannot be simplified. Now I do like the I at the end, so when I rewrite this on the next line, I'm going to bump my letter to the end. Okay, I'm going to subtract 2 on both sides, and I'm going to have P equals negative 2 plus or minus the square root of 2i. So negative 2 plus the square root of 2i and negative 2 minus the square root of 2i. Now you can leave your I in front of your square root of 2. Some people like to write it that way. This is just the way that I prefer it, but either way would be correct.